Welcome back to structural mechanics. This video will be more in depth about the stress and strain curve of a typical steel. I explained this in the previous video fairly quickly, so I'll be just repeating this a bit more in depth. So here was the stress and strain diagram we saw last time, the stress and strain curve. Okay, now let's begin at the origin with zero stress and zero strain. Suppose we load a steel, okay? We have the first region here. This region is called the elastic region, okay? So what is the elastic region? Since it's a linear line, we're always going to have a variable which gives us the slope. In this case, the variable is the elastic modulus, okay? Now the reason our line is a straight line is because stress and strain are linear and are proportional. So we produce this straight line. Now some properties of the elastic region. Okay, first of all, it obeys Hooke's law. There are no permanent deformations. This means that if we load it and it hasn't yielded yet, okay. Now just going back here quickly, a point that I didn't mention, the elastic region is before yielding. Okay. Now going back here, no permanent deformations. This means if we load the metal and it stays in the linear region, unloading it will make it go back to its original dimensions. So nothing permanent. Okay, the next point, I already stated this. Stress and strains are proportionals, giving us the straight line. I also stated the fact that elastic modulus is the slope of the line. Elastic modulus, also called as Young modulus of elasticity, it is an indication of a stiffness of a material.